For the final video in this lesson, we're going to discuss some patterns that come about because of multiplying various types of polynomials. And you've run across some of these patterns before when you were working with quadratics. So if we were multiplying two binomials together, or if we were squaring a binomial, it created a certain pattern. And so we'll kind of quickly discuss those. Now you can see here we have a little summary box for you. And this first pattern is basically multiplying two terms that have different signs, and so it results in what we call a difference of squares, and you'll probably remember that from our factoring. The second set is a square of a binomial, and if you recall, we created the square of a binomial from completing the square. And so the result when you multiply a square of a binomial is actually the perfect square trinomial that you dealt with in factoring quite a bit. And so these should be fairly familiar to you. Now, you can either use the given pattern or you can just simply use your distributive properties. Now, this last one, the cube of a binomial, this is a little different than what you dealt with in factoring. We did factoring sum and difference of cubes where both parts individually were cubed. This is where we have an entire binomial cubed, which is a little different. And so there's a distinct pattern whenever you have a binomial cubed, and you can either follow that pattern or you can simply do the distributive process as well. So what I'm going to do here is I'm actually going to show you both ways, and I'll let you decide whether you want to stick to the pattern or if you just want to do the distributive process. So go ahead and take the time to work these sample problems and then come back and look at the different ways and see which one you prefer best. Okay, so for the first one, I'm going to work just the pattern itself. And so we see we have a sum and a difference between these two binomials. And so what I can do is I can actually take the a value and square it, and then of course that's going to give me my difference of squares with my b value squared, which is going to give me 9x squared minus 4, and you can see the difference of squares pattern there. Now most of us would probably go the route of simple distribution or foiling in this case, since we have two binomials. And when we have this difference of squares pattern, we recognize that our middle term is eliminated because the two are conjugates, so we still end up with the same given answer. So you can either choose the pattern method on the left or you can choose the distributive property on the right. Either way works, so use the one that's most comfortable for you. Okay, and so we're going to do the same thing here. We have a binomial squared, and we can use the perfect square trinomial pattern, if you will. So we could do 5a squared plus 2 times a times b plus the b squared. And of course, if I do all of those calculations, I end up with my final answer. Again, you may choose to simply expand this squared to two binomials and then FOIL it, and you can see the middle term is happening twice. That's why we had the 2 times those values, which gives us 20a plus 4, and we come up with the same answer. Now, this last one is a cube, and what I'm going to do is I'm going to do the pattern first. And then after I do the pattern, I'm going to do the distributive property of it, and you're going to have to decide which method you think is easiest or best for you to use. Okay, and so what you can see here is we have our first term cubed and our last term cubed. And in the middle, we have the negative 3 and the positive 3, and they're going to be multiplied times the a squared and b, and then the a times the b squared. And so you'll have to get comfortable with these different patterns in the middle of this, and then it would just be a matter of working through the given parts here. And so we were going to have 8m cubed minus 3, and of course if I distribute the 2 here, when I say distribute, if I do the power properties, we're going to get 4m squared times 3, and then here we're just going to square that. Now notice that this negative is not part of the 3 cubed as far as the pattern is concerned, so we'll negate that 27 in the end. And so now I just need to do all of my multiplication properties, and I have my final polynomial. Now for this last part, what I'm going to do is I'm actually going to expand the 2m minus 3 that I'm cubing here. And I'm going to write all three parts next to each other. Now, what you may decide is that that pattern is too hard to remember up here. And so you may just like to do the distributive process. Well, in doing this, you're going to have to do the distributive process twice. Just kind of like if I multiplied 2 times 3 times 4, you would have to do one of the multiplication parts first and then take that product and multiply it times the third term. What I'm going to recommend that you do is actually work with these last two together first. And so I'm just going to bring down this 2m minus 3. Now when I multiply 2m minus 3 times 2m minus 3, I actually have a binomial squared. So you can either FOIL this or you can use the binomial squared pattern. Regardless, you're going to get 4m squared minus 12m plus 9. Now we're back to our original multiplication problem where we have a binomial times a trinomial, and I can simply distribute the first term, which will give me the following terms. Then I can simply distribute the 3 to every term, which gives me the remaining terms. And then it'll be a matter of just combining like terms from here. And that gives us the same answer as what we had up there. And so whenever we use the pattern or whether we use the distributive process, we're going to finish with the same exact answer. So you'll have to make that choice so that you don't make mistakes and you come up with the correct answer.